So in math class, we solve lots of problems that don't always have a solution, right? So let's look at a couple of examples of problems that maybe don't have a solution. So we're going to start by graphing the ordered pair y equals 2x minus 5. So where am I going to begin? What is my y-intercept? B equals -5. What is my slope? It's just 2. X is not part of slope. It's 2. So that's the same thing as 2 over 1. So that means that I'm going to go up 2 and to the right 1. So I'm going to begin at -5. I'm going to put a point at -5 on the y-axis. And then from there, I'm going to go up 2 over 1. Up 2 to the right 1. Up 2 to the right 1. And I'm going to repeat that pattern. I'm just going to keep repeating that pattern. Okay? So when I'm done with that, I am going to connect my ordered pairs. And hopefully a nice straight line. Okay? So it says give the ordered pairs of at least 4 points that are on this line. So what are 4 points that are on this line? 2, -1 is one of them. Yeah, write that ordered pair down. 2, -1, we're going to let someone else give a shout out. That's all right. Owen. 3, 1. Tim.
5, 5.
How did that change colors on me right there? Did you guys see that? That is so weird. 5, 5. Kenna, give me one. I'll color red the points that have been labeled. We said this point, we named this point, and we've named this point. Give me another. Sorry. 3, 2. 2, 3. Nope. Ken? Oh, you said 3, 4. I'm sorry. 3, 4. Yes. Ken, what do you have? We're saying ordered pairs. Ordered pairs. -1/3 is a fraction. I need an ordered pair. 1, 3 is right here. Is that on the line? That would be a -3. 1, -3. You said -1/3. We got to know how to name ordered pairs, guys. Got to know how to do that. Okay. All right. So graph the line. Check. We've already done that. Is the point -17, -39 on this line? No. How do you know?
Because X goes by 1, and I did not. Once it hits 17, it's only at 29 on the Y calculator.
Let's check. So we're going to take this ordered pair. This is my X, and this is my Y, and we're going to plug it into this equation. Y equals 2X minus 5. So Y is -39 equals 2 times the X coordinate, -17 minus 5. What is 2 times -17? -34. And what is -34 minus 5? Oh my gosh. Does -39 equal -39? Yes. So what does that mean? Yes. The ordered pair -17, -39 is a solution. Meaning it lies on the line. That's how you check. You got to plug it in and check, okay? So now let's consider the equation y equals -1/2 x. So let's graph this equation. I'm going to graph this one in red. What is my point of beginning? Where do I begin on this one? Victoria. What is my y-intercept? Y equals -1/2 x. What's the value of b? Remember that our equations are written in this form, Victoria. Y equals m times x plus b. What are we adding after that x term? Are we adding anything? Victoria, do you see this equation right here? Are we adding anything after the mx term? Are we saying plus some number? Do you see this? Y equals negative 1/2 x. Are we saying plus 1, plus 2, anything like that after it? No. So what does that mean for your y-intercept? Well, you do have one. It's 0, right? Remember, we just don't write plus 0. Your y-intercept is 0. What is my slope, Avery? Negative 1/2. Negative 1/2. So that means I'm going to have to go down and to the right 2. So I'm going to begin at 0. And I'm going to go down 1 and to the right 2. Down 1 and to the right 2. Down 1 and to the right 2. I can also go up 1 and to the left 2. Up 1 and to the left 2. Up 1 and to the left 2. Okay. So let's list some ordered pairs that live on this line. Give me one, Brianna. Two, negative 1. Good job. Michelle, give me an ordered pair that lives on this line, on the red line. Negative 2. This point right here is negative 2, 1. I know she did. 2, 4 is not on there. Go show me. You go point to it, Ken. It's negative 4, 2. Correct?
Yeah.
Okay. Tyler, give me an ordered pair that's on the red line. Perfect. 0, 0. Daniel, give me another ordered pair that's on the red line. I'm not seeing where you guys are getting negative 2, 4. Explain to me how you're reading that. Are you guys saying, I think I know what you're doing. You're doing this, negative 2, 4. Are you guys saying the y coordinate first? Okay, x comes first. X comes first. So this is the ordered pair 4, negative 2. You have to say the x coordinate first. 4, negative 2. Okay? All right, so graph the line. We've already done that using a different color. We did that too. Are there any points that lie on both lines? Yes. Which one? 2, negative 1. Okay. Why do you think that lies on both lines? What do you think that means? Yeah, the ordered pair 2, negative 1 is a solution to the system. Now I have to say what two equations are in my system. So my first equation I used was y equals 2x minus 5. And the second equation I used was y equals 1/2 x. So that is my system. So question number 3, we're still using this same grid. We're still going to use this same grid, okay? Question number 3 says, now let's think about the line 6x minus 3y equals 15. Find the x and the y intercepts. Find the x and the y intercepts. Well, remember that the x-intercept happens when y equals 0. So we can just cover up the y. That gives me the equation, what?
6x equals 15.
Yeah. Divide both sides by 6. X equals, let's see, these are both divisible by 3, 5 halves. So the x-intercept is the ordered pair 5 halves, comma 0. Let's look at the y-intercept, or y-intercept. So if I want to find the y-intercept, cover up the x. So I'm going to put a big old box around it and just put a line through it. So that gives me the equation negative 3y equals 15. Divide both sides by negative 3, which means I cross the y-axis where? At negative 5. That's the ordered pair 0, negative 5. It also asks me to find the slope of that line. If I want to find the slope of that line, I have to put it in what form? Slope-intercept form, yeah. So I'm going to take this equation, 6x minus 3y equals 15, and I'm going to solve for y. So the first thing I need to do is subtract 6x. That gives me negative 3y equals negative 6x plus 15. I'm going to kind of drive that up here so I have a little bit more space. So negative 3y equals negative 6x plus 15. What do I do now? If I'm trying to get...
You divide it all by 3.
Yeah, by what?
By negative 3.
Good job. Going to divide every single term by negative 3. Every single term by negative 3. So y equals a negative divided by a negative is a positive, and 6 divided by 3 is 2. So y equals 2x. 15 divided by negative 3 is negative 5. So my slope is 2 over 1. My slope is 2 over 1. So let's graph this line. Let's graph this line. Let's use this point right here and then count our slope. Are you okay with that? So let's start at 0, negative 5. I'm going to graph this line in green. So there's the point 0, negative 5, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. What do you guys notice? Yeah, it's the exact same line as the blue line. So this is the same line as the equation y equals 2x minus 5. So all of the points are shared, right? If the two lines lay on top of each other, then they share all of the same points. All of the same points. Does that make sense? Okay. That would be like an example of an infinitely many solutions. If I graph the two of those together as a system, if they lay on top of each other, then they intersect everywhere, right? So that would be an example of infinitely many solutions. So we graphed it and we noticed that it's the same line. We're done with that. So last one says use a different color on the graph and graph the line. Oh, sorry. Use a different color to graph a line that shares no points with y equals 2x minus 5. No points. So if it's never going to share any points, it means that they're never going to do what? They're never going to intersect. So what kind of line do we need to draw? We need to draw a parallel line to our green-blue line. So I'm going to put that in orange. So where do you want to cross the y-axis? At negative 1. Okay. And then it has a slope of 2 over 1, up 2 over 1, up 2 over 1. We could also go down 2 and to the left 1, down 2 to the left 1. And when I graph this line, I see that I've graphed, I'm going to say what this equation is. So we crossed at -1 and it has a slope of 2. So this is the equation y equals 2x minus 1. That's the equation y equals 2x minus 1. So what do you notice about the slope? Well, the slope is 2, which is the same as y equals 2x minus 5. But the y-intercept is -1, which is different. Than y equals 2x minus 5. So let's see. If we have the same slope and different y-intercepts, what is that a definition of? Who said that? Good job. That was actually a question on your test, wasn't it? This means that you have parallel lines. This means that you have parallel lines, okay? Same slope, but a different y-intercept. That means you have parallel lines. So let's write some notes about this and see what we can figure out. Let's write some notes about this and see if we can figure it out. Is everybody good with that? Okay. So quick notes. I'm going to draw a little XY axis right here. I'm going to label this X and I'm going to label this Y. And I'm going to give an example of what kind of a solution does the system have? No solution. Yeah. This is an example of no solution. In terms of a system, there would be no solution. I'm going to draw another little XY axes. Notice I'm leaving space at the top because we're going to write a note at the top up there. I'm going to draw another little XY axes, and I'm going to draw a line that looks like this. And I'm going to draw a line that looks like this. And they have this fabulous little point that they share. So what kind of a solution does this have? One solution. Good job, you guys. One solution. And then I'm going to draw another little X, Y axes. And I'm going to draw a blue line. And then right on top of it, I'm going to put a red line. So what kind of a solution does this one have? Yeah. So the idea is a solution, which is an X, Y ordered pair to a linear system, must satisfy or solve, if you will, all equations in the system. We talked about that yesterday. It has to work for all of them. Can't just work for one of them, okay? And then I'm going to write a note here that says a linear system can have 3 types of solutions. It can have 3 types of solutions. It can have just like an equation with one variable. We talked about that yesterday as well. It can have no solution, parallel lines. It can have one solution, two lines with different slopes, or it can have infinitely many. So this is parallel lines, no solution, parallel lines. One solution, the lines have different slopes. If the slopes are different, they will eventually run into each other. If the slopes are different, they will eventually run into each other. Infinitely many means that they have the same slope and the same y-intercept. So you can recognize them without graphing them. Same slope, same y-intercept. So we're not going to do the check your understanding part. We're not going to do the check your